This is a video recording of the answer key for the limiting reactant activity and simulation. For the first experiment, 0.0201 grams is recorded on the balance. This is for the tin reacting with the hydrogen chloride. After the reaction has come to a complete stop, I measured the balloon to be 5.6 centimeters in width. Now I expect your value to vary depending on how it's rendered and how you're actually measuring. Now, using an Alaskan three-step that I call it, we want to determine the grams of HCl that did react with the tin for experiment 1. So I'm going to start with a 0.0201 grams of tin recorded from experiment 1. We'll multiply that by 1 mole over the atomic mass, or molar mass of tin, to get us in moles. And then we'll multiply it by the ratio of 4 moles of hydrogen chloride for 1 mole of tin. And that comes from the balanced chemical equation. If you remember, this is our middle part, which is the stoichiometry. And then we multiply it by 36.5, which is the molar mass of 1 hydrogen and 1 chlorine added together, per 1 mole of HCl. And that gets us 0.0247 grams of hydrogen chloride that's needed to react with the 0.0201 grams of tin. Now in the next question, if the grams of HCl in the actual Erlenmeyer flask is 0.082 grams, basically how much hydrogen chloride is left over? Well, we're going to take the 0.082 that's in the flask, subtract the 0.0247 that reacted with the tin, and that's an excess of 0.057 grams of HCl that's left over. So indeed, our limiting reactant for this question then is our 0.0201 grams of tin. So then the question says, use an Alaskan three-step, determine the grams of hydrogen gas produced in experiment 1. We must use the 0.0201 grams of tin in this Alaskan three-step. Why is that? Because this is our limiter. So 0.0201 grams of tin times 1 mole of tin over the molar mass of tin. And now this time it's 2 moles of hydrogen for 1 mole of tin. And this again comes from our balanced equation. There is a 2 next to the H2 in the equation and a 1 next to the tin in the equation. Then we'll finish up by multiplying by 2.016 grams of hydrogen for 1 mole of hydrogen. And again, this is the molar mass of H2 from the periodic table. And this gets us 0.00068 grams of hydrogen gas. Okay, now we'll continue with the simulation for experiments 2, 3, and 4. The measurements that I got for the balloon, the width of the balloon, was 6.2 centimeters for experiment 2, and then 6.5 for 3, and also 6.5 for 4. Now, because in this experiment we are adding more and more tin each time, when I notice that there's no change in volume of hydrogen gas produced, that probably means we've used up all of the HCl. So no matter how much tin that I add to this reaction, no more of it's going to react, and therefore we won't get any more of the hydrogen gas produced. So I'm guessing experiment 3 is the one that allows the reaction to go to completion for the first time. So I'm going to assume then we have relatively equal amounts of tin in this reaction and hydrogen chloride that's needed to make the reaction to go to completion. So that's why I've chosen experiment 3. Experiment 4 probably has some excess of tin in the experiment that we really can't see, okay, in the solution provided. So I've chosen experiment 3. So it says, determine the maximum grams of hydrogen gas produced in these experiments. Well, I'm going to use my measurements then from experiment 3, because I know that that's the one probably closest to where all of the hydrogen chloride reacts with all of the tin, and there's no excess of either of the reactants. So then I'm going to take the 0.0672 grams of tin, and that's the amount of tin in experiment 3. And again, I'll times it by 1 mole of tin over the atomic mass of tin, or molar mass of tin. And now I'm going to go to stoichiometry times 2 moles of hydrogen for 1 mole of tin. And again, these numbers come from the balanced chemical equation. There's a 2 and a 1. And multiply by 2.016 grams of hydrogen for 1 mole of hydrogen gas. And that gets 0.00228 grams of hydrogen gas that is produced. Okay, and that's our answer key for that activity. Hopefully that makes sense. If you have questions, you can email me about that. And I hope you guys have a super awesome, amazing day.